when you see a fraction where the top number is larger than the bottom, or the numerator is larger than the denominator, something like, let's see, 9/4. What this is telling you is this is an improper fraction, and it can be reduced or simplified. A lot of times you'll have a problem like this on a test or something, and they'll say simplify. So what this is really telling us is take 9 and divide it by 4. So I can write this in the old school way, the longhand division, and then I can do this division problem by asking myself, okay, how many times does 4 go into 9? It goes 2 times. 2 times 4 is 8. Draw a line under it, subtract. 9 minus 8 is 1. So in this case, I have, when I ask myself how many times does a 4 go into 9, it goes 2 times. I can see that right here. It goes twice. And then the remainder, 1 over the common denominator, or the original denominator, 4. So 2 1/4 is the, what we might say is a simplified form of this 9/4 fraction. We could do, or we could look at this a little differently, and this is how I'm going to recommend you actually think about it. If I could just erase that a little bit, give myself more room. When you have a problem, an improper fraction like this, and you're trying to simplify, you don't have to visualize, or you don't have to do this long division step. What I do in my head, I just ask myself, okay, how many times will 4 go into 9? And I know that it'll go twice, okay? And then what is the remainder? So if 4 goes into 9 twice, then 2 times 4 is 8. What is left over? 9 minus 8 is 1. I know I have to write that 1 as my remainder on top, and then write the original denominator down below. That's how I do it in my head. That's, I guess, how I'd recommend you do it. So let's try some more on another page here. So if we had 23 divided by 7, we'd ask ourselves, how many times will 7 go into 23? Well, it goes 3 times. So I'm going to write my 3. And then I'm going to ask myself, okay, 3 times 7 is 21. What is left over? 23 minus 21 is 2. And then I'll write the original denominator down like this to get my answer. Here's another one. How about 45 over 5? I ask myself, how many times will 5 go into 45? Actually, you know what? It'll go 9 times, because 9 times 5 is 45. Hey, there is no remainder. Well, guess what? Then this is just the answer. The answer is just a whole number. It's not actually a fraction. Let's try some more. How about 3 over 2? Well, let's see. How many times will 2 go into 3? It'll go 1 time. And so 1 times 2 is 2. So there's a remainder of 1. And the original denominator down like that. If we have something maybe a little more difficult, 17 over 3. Now, I guess I can't really guess at this, so I'm forced to actually do the long division method. So let me write this over here, long division, and then start this off by asking myself, how many times will 3 go into 1? Well, it won't. So I've got to move to the next step. How many times will 3 go into 11? Well, it'll go 3 times. 3 times 3 is 9. I'll write my 9 down here, draw a line under it, subtract. 11 minus 9 is 2. Okay, bring the next number straight down. It's 27. Now I repeat the process. How many times will 3 go into 27? Let's see. 3 times 8 is 24. 3 times 9. Oh, 3 times 9 is 27. Write the 9 up here. 3 times 9 is 27. Write that down here. Draw a line under it. Subtract. And guess what? No remainder. So 117 over 3, I have 39 with no remainder. So the answer is just 39. So I think you can see that this portion here, if you have like a remainder, you're going to have a remaining fraction with your whole number. And if there is no remainder, then it's just the whole number is the answer. That's how the problem simplifies, just to a whole number.